So 5.2 notes, we're going to be verifying trig identities. So same identities that we were using in 5.1. Those are going to come in handy in 5.2 as well. So if you have a screenshot from your identities from 5.1 notes, you might want to just copy and paste that over to here too. But you're going to use the same identities. It's super similar to what we were doing in 5.1, but there's just one little difference, and I'll show you the way that the questions will look here. So when we're verifying trig identities, it's going to be an equation. You're going to have one side equals another, and your job is to prove how they're equal. So the steps for the trig identities, to verify your trig identities, is to work with one side at a time. You can't move something from one side to the other. Your goal is just to simplify one side at a time. You want to look for opportunities to factor, to add fractions, to square binomials, or to create a monomial denominator. Look for opportunities to use the fundamental identities. When the preceding guidelines do not help, try converting all terms to sine and cosine. And it says always try something. So just try to simplify. If you don't know exactly how to get from one side to look like the other, just try simplifying and it might take you somewhere. So these are kind of similar to like proofs in geometry, except there's no vocab. You don't have to say what you're doing. You just need to simplify. So example 1, we're verifying the identity. So here we have an equal sign. So that's the difference between what we were doing before with simplifying and these. So right down the middle of my equal sign, I'm going to put a line. I'm going to draw a brick wall here. I want to simplify to make these sides be the same, but I can't move from one side to the other. I can't cross multiply. You can't add something from one side to the other. We're just simplifying one side at a time. We always want to start with the more complicated looking side to see if we can simplify that to the other one, because it's going to be easier to simplify than it is to like expand something. So which side would we start with here? The left side. It's a little bit more complicated than the right. So how could I simplify the left side? I could do what? Find the identity of the top. So secant squared minus 1 would be the second one. I'm going to subtract 1 on both sides. So we have tangent squared equals secant squared minus 1. So I'm going to replace secant squared minus 1 with tangent squared. Now it's super important here that you're showing every step, because the simplifying process is what you get graded on, is your work. So I simplified secant squared minus 1 into tangent squared. So I have tangent squared theta over secant squared. Now tangent squared over secant squared still doesn't equal sine squared. They're not the same yet. What else could I do to simplify? Perfect. I can change everything to be in terms of sine and cosine, so I can make tangent squared sine squared over cosine squared over 1 over cosine squared. Now what do we do when we have a fraction and a fraction? Keep, change, flip. We're going to keep the top change to multiplication. We'll flip the bottom to cosine squared over 1. Anything simplify here? The cosine squareds will cancel. And what are we left with? Sine squared. What was our goal to make it equal? Sine squared. So what you're getting graded on is your work. So it's super important. Show every step. You cannot just do this in your head. You got to show every step that you're simplifying. The WebAssign for this is not fun, because it wants you to simplify exactly how WebAssign wants. But for the WebAssign, just treat it as a PDF. Just download it into Notability. You don't have to type anything into WebAssign. Just show your work for what you're turning in. So the WebAssign for this, just put it in Notability, do it as a PDF, exactly how we're doing here, show your work. You don't have to type anything into WebAssign. Just use it for the questions. Now, with all of these questions, there's more than one way that you can work these out. If I had secant squared theta minus 1 over secant squared, anything else I could do? Does anybody see anything else that we could do to simplify? That might be a little bit more complicated, but it'll probably still work. Since I just have a secant squared on the bottom, I can split this up into two fractions. So I could say secant squared over secant squared minus 1 over secant squared. What's secant squared over secant squared? 1 minus, what's 1 over secant squared? Cosine squared. And 1 minus cosine squared is sine squared. So you could do it this way too. So there is multiple different ways that you can simplify these. There's more than one correct way to do these. Let's look at example 2. So I'm going to draw a line right down the middle because I can't go from one side to the other. Which side looks more complicated? Where should we start? The right side. Now looking at the right side, it says to add. So we've got two terms here. On the left side, we just have one term. We have a secant squared. So I want to end up combining these together to just be one term. What do I need when I'm adding with fractions? Common denominator. So let's make these have a common denominator. What do I need to multiply by to get a common denominator? 1 plus sign in the first one, perfect. So I'm going to do that here. 1 plus sign, it uses alpha. But if you want to just use x for all of them, that's okay. And then 1 plus sign. And then in the second one, we're going to multiply 1 minus sign. So up top in our first fraction, we have 1 plus sine of alpha. And then plus, in our second fraction, we have 1 minus sine of alpha. And then our denominator, you can FOIL it together if you want. We've got 1 plus sine theta, or alpha, times 1 minus sine alpha. When we FOIL those, we could use our conjugate shortcut, so it'd be 1 squared minus sine squared. Anything simplify? We can combine like terms. So 1 plus 1 would be 2. Anything else? The signs cancel. We have sine minus sine, which would just cancel out. So we have 2 over 1 minus sine squared alpha. What else could we do to simplify? Use our identities. Going over here, we have a 1 minus sine squared, so I can subtract sine squared on both sides. So what does 1 minus sine squared equal? Cosine squared. So I'm going to replace the 1 minus sine squared with cosine squared. So that gives me 2 over cosine squared alpha. What could we do next? Awesome. I can make, it's essentially 1 over cosine squared, which would just be secant squared, but the 2 just stays out front, so it'd be 2 times secant squared, which was our goal. That was what we were trying to make it equal. So it's super helpful when you're working these out. After every step that you do, just glance back over at the other side of the wall that you have to see what's your goal. What are you trying to make it equal? That way you can kind of know what direction to go in. So let's look at example 3. I'm going to put a brick wall right down the middle. Which side do we want to start simplifying here? The left side. Left side looks a little bit more complicated. We've got lots of terms over there. We want to simplify it down to the one term on the right side. What could we do with the left side? We can use our identities. So I'm going to copy our identities over here. All right, so starting with tangent squared plus 1. What does tangent squared plus 1 equal? Secant squared. So it says 1 plus tangent squared, which is the same as tangent squared plus 1, equals secant squared. So I'm going to replace that with secant squared x. And then we have cosine squared minus 1. What does cosine squared minus 1 equal? So I'm going to rearrange the first one. If I subtract 1 to the other side, because it has to be cosine squared minus 1, I also have to subtract sine squared, so it would equal negative sine squared. So cosine squared minus 1 equals negative sine squared. So I'm going to replace cosine squared minus 1 with negative sine squared. What could we do next? Awesome, I can change secant to be 1 over cosine squared. And that's still times negative sine squared. What could we do next? Multiply them together. So I could make it negative sine squared over 1. Multiply straight across, we get negative sine squared over cosine squared. What is sine over cosine? Simplified to. Awesome, so this would be negative tangent squared, which is what we were trying to simplify to. So example 4, I'm going to put a brick wall right down the middle because we can't go from one side to the other. Which side do you think it would be better to work with here?
Right side.
Why?
Because you can multiply one times the side. Or you can change that.
Sure, we can do that side. Remember, we said that we would rather start with the more complicated side first. So I would say the left side might be more complicated because you're adding two terms together, so we could try to combine them by adding. But if you guys want to work with the left, let's do that. What can we do with the left side? Or maybe with the right? We can make them the reciprocal function. So 1 over cosine times 1 over sine. Anything else we could do here? Can't really do anything else on the right side. We can pause here and let's go to the left side. What can we do with the left side? We can make it sine over cosine plus cosine over sine. So the directions kind of gave it away, but you can convert everything to sine and cosine, so that's what we did. Now with the left side, we want to add them together. So what do we need when we're adding with fractions? A common denominator. So I can multiply the first one here by sine over sine. And then the second one by cosine over cosine. So up top, we have sine squared plus cosine squared over sine times cosine. Anything else we could do? Sine squared plus cosine squared is 1. So we have 1 over sine times cosine. And we can just split them. We can split it into two fractions to make it the same as what we are trying to do. So I could say this is 1 over cosine times 1 over sine. So this. Well, once you get it to be the same as whatever you simplified the right side to, you can stop. So if we didn't do the first step on the right side, we could then simplify the left a little bit more and say secant times cosecant. So example 5, I'm going to put a brick wall right down the middle. Which side do you want to work with here? All right, what do you want to do to the right side? Noah. We can't change 1 minus sign because it's not squared. It has to be squared. So what we can do is multiply by the conjugate. So we can multiply the top and the bottom by 1 plus sign, like Noah said, and that way we can get it to be squared in our denominator. So I don't really know what my goal is yet, so I'm going to leave the top as cosine times 1 plus sine. I'm not going to distribute it yet just because I don't know what my end goal here is, but I'll leave it like this. In the denominator, you can either FOIL or use your conjugate shortcut, so it'd be 1 squared minus sine squared, or just 1 minus sine squared. Now what can we do? We can change the 1 minus sine squared to cosine squared. So we have cosine times 1 plus sine over cosine squared. Any other ideas? We can cancel out a cosine on the top with one of the cosines on the bottom. Since that cosine is being multiplied to everything on the top, we can cancel it. So we have 1 plus sine over cosine. So we did some good job simplifying. We did good work here, but it's still not what we need to be on the left side. But any other ideas? What? We can split it. Yeah, that definitely works. We have 1 over cosine plus sine over cosine. So since we were adding and we split it with addition, the denominator stays the same. What's 1 over cosine? Secant. What's sine over cosine? Tangent. And what was our goal? Secant plus tangent. So there we go. I did this in J period yesterday, and they wanted to work with the left side first, so we simplified the left side a little bit, but then we got stuck, so we paused there, and then we simplified the right side a little bit, and then we ended up getting them to be the same. So you can work with both sides, you just have to do one side at a time. You can't move something from one side to the other side. It just has to be one side at a time. Any questions here?
Okay, so let's say you were to reach halfway.
All right, last one, example 6. Which side do you want to work with here? Sure. What could we do to the right side? Signs can't cancel because we're subtracting the sign up top. We could split it. So I have 1 over sine of theta minus sine over sine. What's 1 over sine? Cosecant. What's sine over sine? 1. So we got cosecant minus 1. Still not what we wanted. Still not at our goal yet. Any other ideas with the right side? We could pause here and let's look at the left side. Any ideas of what we could do with the left side? We can multiply by the conjugate, so 1 minus cosecant. So I'm not sure what my goal here is yet, what I'm really trying to do. So I'm just going to leave it as cotangent squared times 1 minus cosecant. I don't want to distribute it yet because I don't know what's going to simplify. So I'll leave it like this for now. In the denominator, we can use our conjugate shortcut. So 1 squared minus cosecant squared would be 1 minus cosecant squared. Not secant. Let's put our identities here so we can see. So cosecant is this one. Oops. There we go. We need it to be 1 minus cosecant. So I can subtract cosecant to move it to the other side. And I have to subtract cotangent squared to move it to the other side. So we get 1 minus cosecant squared equals negative cotangent squared. So what are we going to replace 1 minus cosecant squared with? Negative cotangent squared. Any other ideas? Is the cotangent up top being multiplied? Yeah, so we can cancel them out. So the cotangent squareds are going to cancel. So we have 1 minus cosecant over negative 1, because we still have that negative on the bottom. We can split it up. We can divide them by negative 1, just flip the sign. So we have negative 1 plus cosecant. What's our goal? Cosecant minus 1, which is the same thing, just the order switch. So we can switch the order, cosecant minus 1. So we're not changing the signs. The signs stayed the same here. We just rearranged what came first to make it match. Any questions here?